We're not sure whose that is. 2 people are claiming it at the moment, so we'll see. Okay. So let's review a little bit. All right, put the screens away, please. Let's review a little bit about finding trig values. So if you notice on these first 2 examples, we've got right triangles, and we are asked to find x. In other words, we're looking for a side. So you have to think about the angle that you are given as the reference, and then what the relationship is with that angle to those sides that you are given and that you are looking for, so that you can use the correct ratio.
This is one because I remember there was like junk on the back right there.
Okay, well, I gotta do some more investigating, but thank you. That's okay. All right, so we are given this particular angle, right? Because it's actually not his, but he borrowed it from a friend. So, all right, we're given this particular angle.
Focus, dude. You focus.
So I need you to think about the relationship that these 2 sides are, the one that we are given and the one that we are looking for. So what's the trig ratio that we are going to use here based on the information given?
Hypotenuse and opposite.
We're given hypotenuse and opposite. So which trig function does that mean we have to use? Sine. So we are saying that the sine of 32 degrees is equal to, in this case, 11 over x. So we're solving for x, but x is in the denominator, so we've got to get that into the numerator. So my suggestion on this is that you think of this as sine of 32 over 1, so that you realize you're going to want to cross multiply here, okay? If we cross multiply, we get that x times the sine of 32 is equal to 11, and then think about what we would do to solve. We're trying to get x by itself, so we need to divide by that sine 32. So x is equal to 11 divided by sine 32. I'm not writing out that step of dividing both sides by that, but I think you can see that. All right, we are rounding to the 10th place. So we just plug that in. So x is approximately... Okay, so when we round, thanks Chloe, when we round, we're going to get 20.8 then, right? And we don't have units for that, so we've just got to go with that. Okay, looks good. Now, let's take a look at this next example here. We are given, the angle that we are given is here, so think about what sides we are given in relation to that angle. What trig ratio are we going to use for this one? Tangent. So tangent of 75 is equal to x over 21. On this one, the x is still in the numerator, so that's a good thing. That just means we're multiplying. So we're doing 21 times the tan of 75. And then you're plugging in. So what do we get for that? 78.4. Yes, Aiden, thank you. Okay. All right.
How do you know when it's like x over 21 or 21?
Think about your ratio, right, Chris? Good question. Tangent, we know the ratio for tangent is opposite over adjacent. So we want to think about the fact that we're going opposite, that would be the x, and then the adjacent, which would be the 21. So x over 21. Okay? So it's always in reference to wherever that angle is. Okay? All right. Cosine is adjacent and hypotenuse, right? Okay. Now, if we are looking for angle measures, if we are trying to solve for angle measures, the work is a little bit different. There's a little bit more we have to do. Notice notice this little box right here. So when we are finding angle measures, the way to think about this, I want you to look at this particular problem. If we had sine of theta is equal to x, what we would actually be solving for is the theta. Okay? So essentially, we have to undo the fact that it's got the sign in front of it. So we have to undo that sign or do the inverse sign in order to find our answer. And so if we take the inverse sign, and that's written as sine to the -1, if we take the inverse sign of both sides, the inverse sign of sine, that basically is like opposite operation, so that disappears. So then we get that theta is equal to the inverse sign of whatever that x would be. Campbell.
Is theta a variable or is it like a number?
Theta is a variable that we are solving for. So like in algebra class, you know how we were, the variable was always, like it always seemed to be x that we were searching for?
Yeah.
Here we're searching for theta typically, right? So theta is that we are, what we're looking for. It's the variable. Good question. All right, so for that instance, we're doing inverse sine. In this particular example here, we would have that theta is equal to the inverse cosine. Guys, you need to make sure you see where these inverse trig functions are on your calculator. Most graphing calculators do not have the inverse reciprocal functions. Yours does, which is nice. You have an inverse secant button, an inverse cosecant button, an inverse cotangent button. Most graphing calculators do not, so you have to learn how to plug in a little bit different way. So unless you get in press to test mode, you should be able to use those inverse trig function buttons on your calculator. If you somehow you get into press to test mode, let me know and I'll have to help you get out of that. Okay, so we're plugging into calculator again. We're going to use the inverse trig function, but the idea is still the same, that we're still just going to write our ratio that we see. Based on the angle that we're trying to find, we are looking, think about the side that we are given, and then we're given hypotenuse. Is the side that we're given, that 18, is that the adjacent or the opposite? Excuse me. That's adjacent. So we're thinking adjacent and hypotenuse. So what trig function is that? Cosine. So we're saying cosine of theta is equal to 18 over 23. So then, based on what we just talked about up here, to solve for that theta, we are going to take the inverse cosine of that angle measure. So theta is going to be equal to the inverse cosine of 18 over 23. So what do we get? That theta is equal to how many degrees? 38.5, yes. So 38.5 degrees. Beautiful.
Did you say you have a quiz?
Quiz. It's just a quiz. All right, let's take a look at this one as well. So based on this angle that we are given up here, think about the sides that we are given in relation to that. What's the trig function that we want to use here? Sine. It's opposite, right? Sine of theta is the opposite side from the angle over the hypotenuse. So in order to solve then, we are going to take the inverse sine So theta is going to be equal to the inverse sine of 5 over 21. And what does that give us for degree measure? 13.8 degrees. Beautiful. All right, questions? We're about to solve the full triangle. We're only doing 2 examples from that next on the back page. Questions? All right, onward. Let's see, which one should we do? Let's do 13. and 16. Yeah, why not? Okay. So if the directions say solve the triangle completely or solve the triangle, something to that effect, notice what it says over here. It says that means to find all the sides and all of the angle measurements. And in other words, find anything that's missing. Okay? If you are already given an angle measure, in my opinion, it is really fast and easy to find the other angle measure. So I always do that first, just to get that done and out of the way. So how do we figure out what angle B is equal to here? What's the relationship in this triangle? Okay, so 180 minus 90 minus 72. That's one way you can do it. The other way is to realize if we do 180 minus 90, then what that's really telling us is that this angle plus this angle has to be equal to 90, right? Because 180 minus 90 leaves us with 90. So these two angles right here are complementary, right? Okay, so 90 minus 72, that tells us that the measure of angle B is 18 degrees. Okay? All right, here's the deal though. I am not going to use 18 degrees in any of the calculations that I am doing, because if I make a careless mistake and I have a wrong answer there, then if I'm using that answer again to solve other problems, then it's all going to be wrong. So I want to go by what I'm seeing there, what I am given. Okay? I want you to think about the fact, guys, side BC can also be written and also is known as side A, in other words, little a, right? And side AB, this side right here, we know it's our hypotenuse, but that can also be referred to as side C. So I'm wanting to remind you about the different ways that these can be written so that you're kind of keeping track of kind of the format or notation, that type of thing, so it doesn't confuse you. Okay? All right. Let's go ahead, let's find side A first. So if we're going to focus our attention on finding side A, then we are looking for this side. We have this angle, and we are already told what that side is. So what's the trig function that we would want to use to figure out side A? Tangent. We're going to say tangent of 72 has to be equal to opposite, which in this case is that side A, over 15. So then to solve, we're going to do 15 times the tangent of 72. And if we plug in and we round to the nearest tenth, what does that give us? 46.2. Sounds good. Okay. We're also looking for side C. For me personally, I do not want to go to Pythagorean theorem at this point. I would rather use that kind of as a check after the fact. I still want to use my trig so that I can use Pythagorean theorem kind of as a check afterwards. Okay, so think about that for a second. At this point, we do have that side. Here's the issue as to why I don't like using the Pythagorean theorem. I've rounded this answer, and so that rounded answer can affect this overall answer for side C also. God bless you. So that's the other reason why I would rather use the information that I am given rather than going on and using something that I just figured out. Okay? So to find side C, I'm looking for the hypotenuse. I have this angle, and I have the adjacent side. So which trig function are we going to use? Sorry, say that again? Careful, we've got this angle, we've got this side, and we've got hypotenuse. So that should be cosine, right? This side is adjacent to that angle. So we want to use cosine of 72 is equal to 15 over little c. And once again, this is a case where, think of this as, we got to cross multiply here. We've got c times the cosine of 72 is equal to 15. So 15 divided by the cosine of 72, and we want to round our answers to the 10th. So what does that give us? 48.5. Okay. All right. Now, if you wanted to check to kind of see if it looks like we did the work correctly, now is when I would suggest you can use Pythagorean theorem. So 15 squared plus 46.2 squared, take the square root of that. You might not get exactly 48.5, but you should be pretty close. So do you want to check that? Let's see how close we are.
49.6.
Okay, so 15 squared plus 46.2, and then you square root it, and we got what?
I got 49.6.
49.6, so we're off a little bit.
I got 48.
I probably did it.
Check your numbers again. So 15 squared
48.6.
plus,
Oh, I did 18 squared.
yeah, 15 squared plus 46.2 squared, and then take the square root of that. It should be, I would like to think it would be closer to 48.5 than that. Try that, what'd you get?
Yeah, 48.5.
Okay, okay, so you're getting, so we're close, right? So that seems like that should be accurate. Good,
So
okay.
on our quiz, like, are you just gonna do it based off like close?
Well,
'Cause
that was our
everyone's
check
different.
to see that it seemed like our work was correct. So that's basically confirming to me, okay, we did this right and we don't have any mistakes.
Well, like, say we did Pythagorean theorem or whatever instead of the codes or whatever, and we put like 48.6 as our final answer, would that be a point off?
It would depend on your work. I'd have to look at it. But I'm gonna be looking for those trig functions really more than Pythagorean theorem. Typically. Okay, all right, let's look at number 16. So notice what we are looking for. We're looking two angles that we have to figure out. We have to figure out angle D and angle F. And then we also have to find side DF, which I'm gonna also write over here, right? That's also side E. It's the hypotenuse that we're looking for. Okay. I'm gonna wait. We're gonna wait to find that side. We're gonna do that last. I wanna find angle measures first, okay? Because I want you to be able to focus on those. If we are looking in reference to this angle D, and we are given this side and this side, which trig ratio are we going to use? Tangent. So we're going to say that the tangent of D is equal to 22.5 over 21. And we're solving for an angle measure, so remember you're doing inverse tan, right? So inverse tan, oops, all right, let me fix this, sorry. I'm getting ahead of myself. So D is equal to inverse tan of 22.5 over 21. So what do we get for angle D? Yeah, 47 degrees. All right.
Should we just like,
Once again, I'm going to use trig. I'm not going to subtract because if I've rounded or if I've made a mistake with that math, my answer is going to be wrong. I'm more likely to be able to get something correct if I'm going back to what I am given. Then that also puts us in the position where we can kind of use it as a check at the end. So for tangent of F, I want to think of the ratio, you got to work the other way, right? This is my opposite now, and this is my adjacent. So 21 over 22.5. So my inverse tan of 21 over 22.5. So angle F gives us 43. Okay, so now, here's the reason why I'm doing that also, because now I can use that as a check, and I can check to see, does that add to 90 degrees, and it does. So it's kind of checking and verifying, okay, I'm correct on that. I know I've not made a mistake, right? All right, we've got to do Pythagorean theorem to get that other side. So 21 squared, I'm sorry? We're given those sides so we can find that other. So we do have to use those in order to get that last side. To get side E. Okay, so 30.8 approximately. Sounds good. Okay. All right, so you've got about, when do we go 10:10? You've got a little over 10 minutes that you can work on the classwork and homework. It's the next few pages. It's pages 18 and 19, okay? And then make sure you do a little bit of review. Go back over and look at your vocabulary. Work through your notes packet again. Up to page 16 is going to be your, and then this first part of this, so actually up through page 17, 18, 19, I guess, is what's going to be on your quiz on day 1 of this next week.
The homework 17,
Okay.
18, 19?
You've done 17, so homework is pages 18 and 19. And I'm going to float around and help you with that, okay?